Each of the letters in the table here represents one of the numbers 1, 2, 3, and each of these numbers occurs exactly once in each row and exactly once in each column. So it's exactly like a Sudoku of 3 by 3 in which 1, 2, 3 have to come in each column, each row, and exactly once in each column. What is the value of R? So we need to find the value of R. Now let's quickly understand one basic fact, that since every row has to have the numbers like 1, 2, 3, so sum of each row should be equal to 1 plus 2 plus 3, that is 6. Sum of each column should be equal to 6 as well. So based on this information, we have to look at these statements. Let's start with the first statement here. The first statement says that v plus z is equal to 6. Now the sum of the two numbers is equal to 6, then both these numbers must be equal to 3 each, because 3 plus 3 equal to 6. Now let's start with this here, that v is equal to 3. That means 3 cannot come here, 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 because in the same row and the same column 3 cannot appear. Okay, 3 can very well come here, but in the same column and in the same row 3 cannot appear for the next time. Similarly, z should also be equal to 3. That means this part is 3, so this row entirely goes off. That means neither t can be 3, now x can be 3. In that case, since the first row has to have somewhere 3 and this is not these two cells, that means R must be equal to 3. That's the only possibility, because if this S is not 3, T is not 3, while one of the 3's definitely has to come in the first row, then it has to be R. So R is equal to 3. That proves that the first statement alone is sufficient, and we are left with two choices, option A and option D. The second statement here says that s plus t plus u plus x is equal to 6. S plus t plus u plus x is equal to 6. So how is this possible, and when is this possible? Now, if 3 comes at one place, then the sum of the remaining numbers will be 3, which is not possible because we can't break it up like this, because 1, 2 and another 1. Let me see. So is that a possibility? No, that's not a possibility. All 3 cannot be 1, and we cannot make any distribution. So the only possibility of distribution of 4 values which sum up to 6 out of 1, 2, 3 is that they are 1, 2, 1, 2. That's the only possibility, that their sum is 6. The first case is not possible. So none of these numbers can be 3, because if any one number is 3, the remaining 3 have to be distributed among 3 numbers, so all 3 of them should be 1, while there can be only 2 ones among these 4 variables, because only one can come exactly once in each row or in each column. So that statement once again takes us to the conclusion that S, T, U, X have to be 1 or 2 anyway. Suppose S, T are 1 and 2, because 2, 1 cannot come here, 2, 2's cannot come here, so 1 has to be 1, other has to be 2, but in any order. In that case, R is again left with only one possibility, that R must be equal to 3. So once again we say that the second statement alone is sufficient, because it gives us the unique value of R, and the answer to the question becomes option D. Thank you so much.